right, here is weather lesson 1. Our success criteria for this lesson is: I know I'm successful when I can recount key details and explain how related information goes together to support the main idea. We have a couple vocab words before we read the text. Our first word is insolation. Insolation is a process which solar energy is absorbed by the Earth's surface. So about 1/3 of this energy is reflected back into space. So that means 2/3 of the energy is kept in our atmosphere. And then we have poles and polar air. So the poles just refer to the North Pole and the South Pole, which are on opposite ends of our globe. And polar air is just air that comes from these two poles. Our next two vocab words are atmosphere. So the atmosphere is composed of the sky and air. So this is where all of our weather happens. And the equator, which you can see is that thick black line on the globe in that picture. So the equator is central or in the middle of Earth. Areas near and around the equator are tropical or very warm, and we'll talk about that as we read the text. And we're just going to be reading pages 4 through 9, so I want you to just listen and think about what the main idea of these pages are. Let me flip back to the text. It's cloudy today. It's also sunny, rainy, and snowy, hot and cold, calm and windy, dry and damp. Each of these descriptions of the weather is true every day of the year, someplace in the world. We live in the atmosphere, the enormous ocean of air that surrounds Earth. Weather is what's happening at the bottom of the atmosphere, mostly in a layer 7.5 miles thick called the troposphere. So that prefix tropo comes from a Greek word meaning change. And above the troposphere, another layer called the stratosphere extends up to about 30 miles. So that prefix strato comes from a Greek word meaning covering. So the stratosphere covers the troposphere. Living in the troposphere, we feel the weather in the temperature of the air and the wetness of the rain. We see the weather in the puffy clouds and the white snow. We can even hear the weather in the clatter of hail against a roof and the distant rumble of thunder. So here we have a picture of, looks like a canyon, so you can see the clouds at the top. So all those clouds are in the troposphere. Earth's weather is driven by the intense heat of the sun. The sun's energy travels through space in the form of visible light waves and invisible ultraviolet and infrared rays. About 1/3 of the energy reaching Earth's atmosphere is reflected back into space. The remaining 2/3 is absorbed during a process called insolation from incoming solar radiation. So you can remember that word insolation with that prefix in, like incoming. The atmosphere lets sunlight pass through. Sunlight heats the ground, which in turn warms the air near the surface. But the atmosphere prevents most of the heat from escaping into space. This is called the greenhouse effect because the glass windows in a greenhouse trap heat in the same way. Insolation and the greenhouse effect strike a balance and make our planet livable. If Earth's average temperature were to drop by a few degrees, the ice ages would return and glaciers would cover North America and Europe. If the temperature were to increase by a few degrees, the polar caps would melt and the oceans would flood low-lying coastal lands. So here is a diagram kind of showing us how the greenhouse effect works. The sun doesn't warm Earth evenly. At the equator, where the sun's rays are most direct, insolation is several times greater than either of the poles. where the sun's rays come in at a slant. Most of Earth's hot spots are located near the equator, and most of the cold spots are in the Arctic or Antarctic. The unequal heating of Earth sets the atmosphere in motion. Air near the equator is heated, becomes lighter, and rises. At the poles, the colder air becomes heavier and settles downward. Warm equatorial air moves poleward, so it moves towards the poles, while cold polar air moves around the equator, or towards the equator. The constant exchange of warm and cold air between equator and poles is one key to the giant atmospheric patterns that make up the weather. So if we go back to this diagram, we can see that the polar air, which is the blue and pink arrows, are going down towards the equator. And then this red and yellow, orange and yellow arrows show the heat coming from the equator. So there's a lot of heat near that equator. All right, and we will be back with the next couple of pages in a couple days.